Hi team, and welcome back to another APES screencast. In this second screencast of Chapter 20, we'll cover sections 20-3 and 20-4. In 20-3, we'll talk about the major pollution problems affecting groundwater. Simply put, groundwater is underground water. Groundwater is often found in aquifers, layers of water-bearing rock. Aquifers provide about half of the U.S. population with drinking water. Aquifers also supply much of the water used by farms and other agricultural operations. Groundwater can be polluted with things like fertilizers, pesticides, gasoline, organic solvents, fracking chemicals, and leaking sewer or septic tanks. When groundwater is polluted, the pollutants can spread and migrate in what we call a plume. In this diagram, you have a leaking gasoline tank. The leaked gasoline contaminates the groundwater in the aquifer. Once in the aquifer, the gasoline spreads and migrates in the form of a plume. Groundwater cannot cleanse itself very well. This is because of a number of reasons. Pollutants in groundwater break down slowly because 1. Groundwater flows slowly, and as a result, pollutants do not get diluted or dispersed very quickly. 2. There's less dissolved oxygen, and as a result, there are fewer decomposing aerobic bacteria breaking down the pollutants. And 3. There are low temperatures, causing decomposition to be slow and other chemical reactions to be slow. Groundwater pollution is a serious hidden threat in some areas. In China, about 90% of urban aquifers are contaminated or overexploited. In the United States, the Food and Drug Administration, or FDA, has reported the presence of toxins in many of the nation's aquifers. Nitrates have been found in aquifers, which can turn into cancer-causing or carcinogenic chemicals. Slowly degrading or non-degradable waste have also been found in aquifers. Polluted groundwater can be treated in a process known as groundwater remediation. In groundwater remediation, pollutants are removed or converted into harmless products. One type of groundwater remediation is called pump and treat. In pump and treat, water is pumped up, treated, and either re-injected back or discharged somewhere else. A pump and treat system is shown in the diagram on this slide. An example of groundwater pollution is arsenic. Arsenic is a neurotoxin and carcinogen associated with skin, lung, and bladder cancer. Water can be naturally contaminated with arsenic when there are rocks rich in arsenic present in a well. Human activities can cause anthropogenic contamination through agricultural applications, the use of wood preservatives, and glass production. Arsenic can be removed from water by the use of tiny particles or nanoparticles of rust. The arsenic will bind to the rust and then the particles can be removed. We have many ways in which we can use to purify drinking water. We can store water in reservoirs and run the water through a purification plant. We can process sewer water back into drinking water. We can expose water in clear plastic containers to sunlight, which has some purifying ultraviolet light within it. We can use the life straw, shown in the photo on this slide. And finally, we can use Pure, a product made up of a chlorine and iron sulfate powder. Many people see bottled water as the solution to providing people with clean water, but is it really a good solution? Bottled water can be useful, but for most people in the world, it's expensive. The United States has some of the world's cleanest drinking water, but has one of the biggest appetites for bottled water. Bottled water is actually less regulated than tap water, and the use of bottled water can create environmental problems, as shown in the picture of non-point source pollution on this slide. In 1974, the United States passed the Safe Drinking Water Act. This piece of legislation set maximum contaminant levels for many pollutants that affect human health, and as a result, drinking water, with few exceptions, is clean and safe in the United States. In Section 20-4, we'll talk about the major water pollution problems that affect oceans. Ocean pollution is a growing problem. For example, municipal sewage from urban areas in less developed countries is often dumped into oceans without any treatment. This sewage, along with other forms of pollution, make their way to deeper ocean waters where they're diluted, dispersed, and degraded. As a result, coastal, open ocean, and deep water ecosystems are all affected. Ocean pollution can be a problem in the United States as well. During large storms, water treatment facilities can become overwhelmed, and as a result, they will release excess water and raw sewage into the ocean. The sewage can contain disease-causing bacteria and viruses. Sewage and agricultural runoff often contains nitrates and phosphates. These nutrients can cause harmful algal blooms and subsequent oxygen-depleted dead zones. This infographic summarizes the causes and effects of ocean pollution. Pollution can come from industry, cities, construction sites, and farms. It can cause red tides, toxic sediments, and dead zones. An example of ocean pollution is the North Pacific Garbage Patch, an area in the Pacific Ocean that covers 1.6 million square kilometers. The North Pacific Garbage Patch is made up of two gyres, or circular currents. These gyres trap trash at the water surface or just beneath it. Plastic in the North Pacific Garbage Patch doesn't decompose. It only breaks down into smaller pieces. These tiny plastic pieces can then absorb and concentrate pollutants, further harming wildlife. Unfortunately, there's no practical way to clean this up, but people are trying to find ways to do so. The photo on this slide shows a Laysan albatross chick. It's dead, and the contents of its stomach are exposed. This chick was fed by its parents, who feed within the North Pacific Garbage Patch. This infographic shows how long it takes different types of trash in the ocean to decompose. Things range from 2 months to 600 years. This map shows where the two gyres that make up the North Pacific Garbage Patch are located. Oceans can also be polluted by oil. Oil is also called petroleum. When it comes out of the ground, it's called crude petroleum, and then it's refined into its final product. Both crude and refined petroleum are highly disruptive pollutants. The largest source of ocean oil pollution is actually urban and industrial runoff from land. Two notable oil spills occurred in 1989 when the Exxon Valdez, an oil tanker, caused an oil spill in Alaska, and 2010 when the BP Deepwater Horizon, an oil rig, caused an oil spill in the Gulf of Mexico. This is a photograph of the 1989 Exxon Valdez oil spill. This is oil left over from the 2010 BP Deepwater Horizon oil spill. This oil spill was the largest in history. Oil is made up of chemicals that contain long chains of hydrogen and carbon. As a result, these chemicals are called hydrocarbons, and hydrocarbons can kill many aquatic organisms. Hydrocarbons form tar-like globs on the water's surface. These globs can coat the fur and feathers of animals, affecting their insulation and ability to survive. These globs can also make their way onto beaches, affecting fishing and tourism in the area. Heavier components of oil will sink, and these components can affect bottom dwellers that we call benthic organisms. The photo on the slide shows birds that have died as a result of their exposure to oil. An ecosystem will recover faster from an oil spill if it has warm, circulating water versus if it has cold, calm water. We can also prevent oil spills from oil tankers by requiring double hull designs. A double hull design is shown in the diagrams on this slide and adds an extra layer of protection from an oil spill. Let's further highlight the 2010 BP Deepwater Horizon oil rig spill. The BP Deepwater Horizon oil rig was found in the Gulf of Mexico. It was a deep-sea oil drilling rig that drilled about 1 mile into the water. After an explosion and subsequent oil spill, 4.9 million barrels of crude oil were released into the water. It was caused by equipment failure and poor decisions. After the oil spill, the U.S. government developed new standards for offshore drilling procedures. This is a photo of the BP Deepwater Horizon oil rig after the explosion.